All right, so now it's been a while. This was last Thursday is when we last talked about this stuff, right? Been a little bit. So factor theorem and remainder theorem. Factor theorem we had already seen previously. Factor theorem, all that says is that k is a zero of f of x if and only if x minus k is a factor. So those two things go together, right? Hand in hand. If k is a zero of f of x, x minus k is a factor, each one leads to the other. They both have to be true at the same time, okay? We added to that, we'd already seen that previously, but we added to that the remainder theorem. The remainder theorem told us that if we divide f of x by x minus k, now what's the zero of x minus k? K, right? We just said that with the factor theorem, right? If x minus k is well, actually, we don't know that it's a factor necessarily, right? But if we divide by x minus k, that means that we would be doing something like synthetically. What does that mean? That means that we're going to be plugging in the zero of the denominator synthetically, right? That's the number that would go out in front if we were using synthetic division, for example. And then the remainder that we get out, what this tells us, which is pretty interesting and useful, is that the remainder is equal to f of k. Okay, so let's do an example. Let's just remind, because it's been a while, let's just remind ourselves what that means. So if I took the function, let's just pick f of x equals x cubed minus 3x plus 4, something like that, right? Let's divide that function. Let's divide that by x plus 2. Actually, let's make it even, I want to make it clearer. Let's do this. Let's divide it by x minus 2. Okay, how would I do that problem synthetically? How would I do that division synthetically? What would my coefficients be? 1, 0. Good, because I'm missing the x squared term. 0, negative 3, 4. And I put a remainder box under the 4, right? Okay, what number goes out front? 2. Okay, good. The 0 of the denominator is 2. So we'll run that through synthetically, right? Okay, we got to start the chain reaction by dropping this number down. Now what? 2, okay, goes there. I add and I get, which means I multiply and get plus negative 3 is 1. Okay, 2 times 1 is 2. So I get 6. Okay, so what's that telling me then? That's telling me that that's my constant, that's my coefficient of x, and and that's my coefficient of x squared, right? Okay, so that's just telling me that this whole thing is equal to x squared plus 2x plus 1 plus what remains over the denominator? 6. Okay. Can you tell me really quick what is f of 2 equal to? You guys are hurriedly doing some math in your head, aren't you? Oops, that's supposed to be cubed. And that's supposed to, hang on a sec. Oh, no, it's not. Never mind. What is it? That's good. We did it right. What is it equal to? If I plug that into my original one, yeah, I'm going to get 8 minus 6 is 2 plus 4 is, well, we knew that by the remainder theorem, didn't we? right? Because whatever the remainder is, that's the value of the function at the zero of the denominator, right? Everybody get that? Eric, go ahead. Yeah, that's fine. Yep. All right. Okay, sounds good. Bye. Okay, so so that's telling me that the value of the function is 6. So really what this could also be is synthetic substitution, right? We don't really even care about that part. If we just want to know, for example, what is f of 2, this part right here would be, who cares? We don't even care about that part. All we care about is that it's equal to the value of the remainder, which is 6. Okay, see my point? Okay. We can take advantage of that remainder theorem, and we could just evaluate a function synthetically by doing synthetic division, plugging in the 0 of x minus k, and the remainder tells us what the value of the function is at k. All right. So that also, these two go together, don't they? Because if the remainder is 0, what does that tell you about the value of k? If the remainder is 0, that means that when I plug that in, the value of the function is y equals 0. So it's an x-intercept, isn't it? That makes it a 0, doesn't it? Right? That's the meaning of a 0. So if f of k equals 0, then k is a 0 of f of x, right? That's what we mean by 0. And if k is a 0 of f of x, then x minus k must be a factor, which we knew because it divided in evenly with no remainder. Everybody see that? It just all goes together, doesn't it? Okay, so let's look at an example here. So what about one like this? If they're telling us we've got this cubic polynomial, and they're telling us that x equals -4 is a 0 of that function, and they want us to find the other zeros, what could we do? What could we do? They want us to find the other zeros. Okay, so we're going to set our function equal to 0, right? Okay, well, if -4 is a 0, then what does that tell us is guaranteed to be a factor? If x equals -4 is a 0, then what's a factor? X plus 4, x minus -4, which is x plus 4. Okay, so that means I could break this into factors. One factor is definitely going to be x plus 4. What can you tell me about the other factor? If the degree of my polynomial is 3 and the degree of the green factor is 1, what's going to be the degree of the yellow factor that I'm going to multiply by green? Show me with your fingers. What would it have to be? It's got to be 2, doesn't it? Exactly. I could multiply an x to the 1 times an x squared to get an x cubed, right? So the leading term would have to have a power of x squared. In fact, it has to be x squared, because if I distribute, leading term times leading term has to give me x cubed, doesn't it? Right? So I know this is going to be something quadratic, but I don't know the rest of it. So let's just call it, how about, let's just call it q of x, q for quadratic, right? And that whole thing eventually is going to equal 0. Okay, so now how could I find q of x? Because that's what I really needed. I need to know what is that yellow factor, right? How could I figure out what it is? What could I do? Yeah, look at this equation. Let's ignore the 0 for a second, right? We could just, let's get rid of that 0. We're not ready to find the zeros yet. Eventually we're going to, but let's just look at that equation. If I want to solve for q of x, what do I divide both sides by? The factor x plus 4, right? To undo multiplying by x plus 4. Okay, so okay, that's good. Look, those guys cancel, and that allows me to solve for q of x, doesn't it? What's the easiest way to divide that out, simplify that quotient? I'd use synthetic, wouldn't I? Because the bottom is x plus 4, just 1x plus 4. Yeah, so let's do that. If we run this through synthetically really quick, what are my coefficients? What was it again? -7. Okay, and there's my remainder box. And can anybody tell me what has to go in the remainder box? If x plus 4 is a factor, what goes in there? What's the remainder got to be if it's a factor? What's the remainder? Now think about this. If x plus 4 is a factor, that's the same thing as saying x equals -4 is a 0. 0, right? That's what has to go in the remainder box, doesn't it? Right, I have to have no remainder if this is a factor. Something to be a factor means it divides in evenly with no remainder, right? Okay, so I know I get 0 in there. What number goes out front? -4, right? Because they told us that was our 0. So -4 is a 0, hence the 0 remainder. Now I just have to do the rest of the synthetic division to find out what my yellow quadratic factor is. Let's find out. Drop the 1 down. What do I get here? Okay, good. Plus 6. Okay, times -4. Plus -7. Times -4. And it worked. I did it right because I got 0. Okay. So then what's that telling me? Well, my yellow factor is x squared plus 2x minus 15. How about that, right? Okay, so now I'm able to rewrite this guy. Let's take that whole thing and let's rewrite this. My original polynomial. Oops. Okay, we're going to break that up into our green factor, which we already knew that was x plus 4. And now we figured out what the yellow factor is. That's x squared plus 2x minus 15. How about that? Now we can do this thing, right? What we've really done here is by dividing, we have factored it, haven't we? Right? We divided we divided the original function by the factor x plus 4 to get the other factor, the remaining factor, q of x, which we just figured out, and that one breaks apart easily. How does that one break apart? What are my magic numbers? -3 and 5. Maybe you already said that. I just hadn't heard that one yet. Okay, and that whole thing is equal to 0, right? We're finding zeros. So apply the zero product property. X equals -4. Duh, we knew that one. That was given to us, right? That one we already had, but we needed to find the others. Well, there they are. X equals 3 or X equals -5. Good? Okay, make sense? Okay. Let's look at one more. How about this guy? So what do they want us to do? They want us to factor f of x. They don't really want us to find zeros this time. They just want it factored, broken apart into factors. Given that k is a 0, well, they're telling us k is -2. So -2 is a factor of f of x. What does that mean? The multiplicity is 2. Remind me. What's that mean? Say it again. Power of 2. Okay, so that factor shows up twice, right? I get x plus 2 times x plus 2 times something else as my original polynomial, right? Okay, so one way we could set this up, let's do this with long division. Oops. So if we're going to do this with long division, then my original polynomial, x to the 4th plus 3x cubed minus 42x squared minus 172x minus 168 factors into what? What is this telling me right here, all this stuff? What's the factor that goes with -2 then? X plus 2, okay. And the multiplicity squared, okay. So then what's going to be the power of the other, the degree of the other factor? Show me with your fingers. Gotta be 2, doesn't it? Because if I expand that out, aren't I going to get x squared plus junk, right? Well, x squared plus junk times what is going to give me x to the 4th? X squared plus junk times x squared plus junk, right? The yellow factor has to be x squared plus stuff. So it's quadratic. Okay, so we know we're getting some mystery factor, q of x, that's quadratic. Okay, well, we could just divide again, couldn't we? Right? To solve for q of x, I could just divide each side by the quantity x plus 2 squared. Well, what is x plus 2 squared? Plus 4x plus 4. Okay, so I divided by the same thing, didn't I? Treated both sides equally. Okay, these guys cancel, and so that's q of x. Well, how could I solve that? I could use long division, right? Because the bottom is not linear. All right, so let's go through this using long division. What you're all dying to do, I'm sure, is do a long division problem, probably, right? Okay, so numerator goes inside. What goes out front? Denominator. Okay, so x squared plus 4x plus 4. And now we can just go to town here. X squared times what is x to the 4th? Okay, I'll distribute. X squared times x squared is x to the 4th. X squared times 4x is 4x cubed. X squared times 4 is 4x squared. I'll subtract in triangles. X to the 4th minus x to the 4th cancels. X cubes. Let's look at the numbers. We know they're x cubes. 3 minus 4 is what? -1. Okay, so I get a -1 x cubed. X squared. So let's look at just the coefficients. -42 minus 4. -46x squared. Bring the others down. Go again. X squared times what is -x cubed? What is it again? -x. Okay, distribute. -x. Distributing through, I get -x cubed minus 4x squared minus 4x. Subtract in triangles again. Negative x cubed minus negative x cubed cancels. Now let's look at the x squareds. Negative 46 minus negative 4 is negative 42. Good, because I'm adding. So I get negative 42 of those x squareds. How about the x's? Negative 172 minus negative 4, negative 168. Bring this guy down, right? Okay. Last one. X squared times what is negative 42x squared? Okay. Distribute through, I get negative 42x squared. Negative 42 times positive 4x is minus 168x. Negative 142 times positive 4 is negative 168. Is it a surprise that our remainder is 0? No, it had to be, didn't it? Okay, so everything cancels and I get 0. Whoops, I get 0 remainder. And so we know what q of x is. Q of x is x squared minus x minus 42, right? And so we can rewrite our polynomial then. Man, this is a lot of stuff, isn't it? So we've got, if we're going to factor this, x squared, or x fourth, x to the fourth plus 3x cubed minus 42x squared minus 172x minus 168 is going to break apart. Can I grab that whole thing right there? Oh, I can't do it, darn it. That's going to break apart into what? So, undo, there we go. So it's going to break apart into x plus 2 squared, right? That's what we divided by, times q of x was x squared minus x minus 42, right? Now we just found? We just substituted in q of x. That was q of x, right? Okay, that breaks apart again. What does that break apart into? What magic numbers multiply to negative 42 add to negative 1? I heard it. Negative 7 plus 6, right? Done. Okay? See what we did? By dividing x plus 2 squared, we figured out what the other factor had to be. Okay, that was pretty tedious. Would you like a quicker way to do that? I bet you would. I'm guessing you would. Oh, I got a quicker way. I got a much quicker way here. Okay, so you got it, because it's not about just being able to solve one problem. It's about understanding how to solve all problems. You know what I mean? So, oh, darn it. Man, I can't seem to. There we go. Okay, so that's what we're trying to grapple with. Okay, agreed. That's where we were. Okay, so what we did the first time, we expanded out x plus 2 quantity squared and used long division. Okay, but couldn't we just divide each side by x plus 2, get a result, and then divide again? See what I'm saying? Dividing by x plus 2 squared is the same thing as dividing by x plus 2 and then dividing by x plus 2 again, right? Okay, so we could do this. We could take our original polynomial with coefficients 1, 3, negative 42, negative 172, and negative 168. And if I divide that by x minus 2 once, that means that the 0 is minus 2. what's the remainder going to be? 0, right? Because x plus 2 is a factor of this polynomial. In fact, it's a factor twice. So how many times should I be able to run that through synthetically and get 0 remainder? 2, because the multiplicity is 2. It's got to divide it evenly 2 times. Okay, so we already know this is going to be a 0. Okay, so what are we going to be left with when we divide our original polynomial by x plus 2 once? Okay, well, let's find out. I bring the 1 down. 1 times negative 2 is negative 2 plus 3 is 1. Times negative 2 is negative 2 plus negative 42 is negative 44. Good. Times negative 2 is positive 88. I add those up and I get, what do I get? I get 64. No, 84. Yep. So I get negative 84. Negative 84 times negative 2 is positive 168. So they add to 0. Huh. How about that? Okay. It divided through with no remainder, but I got to be able to go again. It's got to be able to go through twice, doesn't it? Okay. So we can nest our synthetic division. Check this out. We'll take that result and we'll just make another bar, but now, or another bracket, but now the remainder is under the negative 84, right? Because what did this mean? This just meant this is the polynomial we get when we divide by x plus 2, right? So it's got to go in again. So what goes there? 0. Yes. Okay, and we can run this through one more time. And just as a reminder, we can do this because the multiplicity is 2. So we get to run it through twice. Okay, now we're going to get our yellow factor, right? Now that we've run it through twice, we should figure out what q of x is. So I bring the 1 down. 1 times negative 2 is negative 2, plus 1 is negative 1. Negative 1 times negative 2 is 2, plus negative 44. I bet that's starting to look familiar, isn't it? Negative 42 times negative 2 is 84. They add to 0. We've seen that before, haven't we? That's q of x. So that's x squared minus x minus 42. How about that? How about that? Okay. If I run it through again, am I going to get, if I were to do that again synthetically, would I get 0 for a remainder? Probably not. It's possible. Actually, we didn't, right? Because we found out the other zeros were, what, like 3 and negative 5 or something. So we didn't get negative 2 as a 0 again. So we would have gotten a remainder if we tried it again. It wouldn't have done anything, right? Make sense? But we knew it went in twice. That's a lot. Okay, is that enough for one day? Okay, I'm getting some vigorous nodding on that. All right, that's good for today. You guys, I'll put the assignment up.